So, hello everyone. Thank you for joining us today for our HashiCorp Solutions Engineering Hangout. Today, the Hangout will be hosted by Mark Chua. So today we're going to talk about HashiCorp's Nomad and Consul Connect. Nomad is a simple and flexible workload orchestrator to deploy and manage containers and non-containerized applications across on-prem and clouds at scale. Consul Connect provides service-to-service connection authorization and encryption using mutual TLS. So in this webinar, Mark will show you how to build scenarios of deploying a polycloud environment using cross-workloads. You will also see how Consul ties these workloads from both a security and routing point of view. So I want to note that the Hangout is being recorded, and the recording will be made available to you after post-processing. Usually takes 2 or 3 days, so I'll email it out to all of you, and it will also be available on our website in our resource library. So the demo, Mark will do the demo, and then the remaining of the time we will do a Q&A. So please submit your questions throughout the presentation and demo in the Q&A portal, and we will answer them at the end. So with that, I'm all set, and you can go ahead and get started, Mark.
Awesome. Thank you so much, Brianna. Good morning, folks. Good afternoon to other folks who are in the different parts of the world. Appreciate your time actually joining us in this webinar. My name is Mark Chua. I'm one of the solutions engineer here in the New York Metro, primarily working on the global segment, basically like mostly on the doing a lot of the low latency and compliance stuff with some of like the financial sectors. So it's a very relevant topic what we're having right now, since like it's something like that's dead set into my into my segment. Prior to this, actually, I used to be a solutions engineer actually for Rackspace, for Sabis for the past 10 years, and basically an application developer for prior to that, right? We are going to be talking about Nomad and Consul in conjunction, so that we can see it as we can definitely see it as a solution, not a point product, so to speak, and how it addresses some of like the needs outside in the market. So with that, let me actually share my screen. So let's get started. I'm glad to be able to present this to you regarding what we can do actually as HashiCorp for a multi-cloud strategy, using Nomad as an orchestrator and Consul Connect as a service mesh layer. So before we get started, I'd like to talk more about a lot of the agendas. To start off, Brianna did some introductions as well. I will be talking an overview of Consul and Nomad from a high level, just to make sure that some folks who are on the phone who are not familiar with the product set itself can have a better understanding. After which we'll dive into a demo of basically focusing some of the infrastructure scaling capabilities using Terraform with Nomad, as well as job scheduling, basically from a single cluster deployment to a multi-cluster deployment. And after which, we're here to answer a lot of your questions. If you do, please feel free to put it in the chat as well, and please let us know if you have any questions during the Q&A portion. If there's any other questions that we couldn't really answer, I mean, nobody really knows everything. I mean, we can definitely do a follow-up right after that. So like I mentioned earlier, the objectives of this webinar is basically to provide, but the bottom line is it's to basically provide folks who are transitioning mostly from on-prem to cloud, or basically moving to a dual cloud strategy that we typically see right now from our customer base. What are the options out there? What are the scaling capabilities that you can do from an orchestration standpoint? How would you schedule certain workloads diversely? Let's say if you want to be able to do Docker. I mean, what are what are the caveats around that? What are the caveats of moving in a QEMU driver or maybe a Java driver? I mean, should you refactor those? Those are the things that you need to understand first before you actually need to do a migration, or perhaps do some scaling requirements, right? Number two is basically on the app deployments. So we're going to be deploying some sample layer 7 apps, just so that you can see how we can do some routing capabilities around those. so that like you have like the options to do, let's say like a canary deployment or like an A/B testing deployment as well. Lastly, it's like the service discovery capabilities of Consul, how that actually interacts with the, uh, with the service mesh, as well as like the infrastructure auto discovery capabilities, so that we have so we can actually automatically understand where our resources on the orchestration layer, regardless of where you deploy your clusters. So typically, this is like what we see, like I mentioned earlier, like it's like this is like basically the cloud operating model that we see as HashiCorp. It's a very generational transformation that we're seeing at this point, where most folks are starting from static infrastructure and moving into more dynamic infrastructure, right? And that also goes with your application going from a monolith application, basically being parsed into microservices. Depending on which camp you are, there is also a pros and cons on each need. So when we start talking about the application delivery lifecycle, I mean, like, how do you adapt to that, right? So if we are moving like from a single or multi data center, like with pretty specific bounds or perimeters, and then you start moving into like the multi-cloud, where it has the capability for scale. It's pretty much software defined. A lot of them can be API driven. Then what are like your options around that, right? At the same time, making sure that like if you do have if you have like your what we term to as like your systems of record, like your mainframes, like your like a legacy systems, which holds a lot of like your critical data that can't still be moved into the cloud. What are like your options there? At the same time, being able to take advantage of the economies of scale of the cloud, right? So this is like where HashiCorp really comes in. So we basically provide you with, or basically see this in terms of like a couple of layers, right? So the plumbing down there is what we see more as the infrastructure. So we provide like the capabilities of Terraform, which basically are the operations of infrastructure as code. So for the folks who do not know what Terraform is an infrastructure as code product that we provide that interfaces like with the APIs of like your cloud provider. It gives you the capability to be able to abstract some of like these construct into like one single language, so to speak, using HCL. So it's a lot easier for folks to be able to just code something in one language with a proper API wrappers around that, and have like one single workflow to deploy, either if you are in Azure, GCP, AWS is the world, right? The second part is the security portion of it, which basically states that like if we are moving to a dynamic infrastructure, then what is the basis for it to make sure that like we understand like what are like the options out there. So if you're moving outside, then like your perimeter actually gets broken. Then we move more into like what we term to as workload or identity based security. The third part for that is, now that like my workloads are moving outside of like my data center, or in different locations, so to speak, like the AWS deployments or like your GCP deployments, then how do we provide a means of like identifying where those workloads are? Number two is giving the capability of like securely having a means of providing secure transport between two workloads, and being able to identify those workloads in a certain manner. And we'll talk more about that regarding Consul. And the last part, which is the meat of this webinar, is given the fact that like we are moving applications in different locations. I mean, Docker is a primary driver right now in the industry, but think of it this way, where folks who are trying to do some of the refactoring, there is a financial and time penalty included to that. So is there any other options out there that gives me a way to be able to schedule this workload and get like the efficiencies of scheduling Docker? And also being able to like understand, like if I want to schedule something, I don't want to be tied into like one single corner and then not being able to scale within a specific region. I want to be able like to use the same workflow if I want to be able like to deploy it in different locations as well. So as a matter of overview, Consul is basically our service discovery, service registry, and service mesh solution for folks that gives you the capability for health monitoring and being able to register all your services, giving you one single pane of glass to be able to see like where they are, and also provide some level of metadata around that, right? So if I have a web server and I need to be able to give some ways of meanings around that, like a metadata, then basically that's what we can actually provide you with, like with this capability. The other part, what we term to is middleware automation, is as you can see on the screen right here, is given an abstraction to be able to self-register any of like your applications behind a load balancer such as F5 or Nginx, and add that into the registry as well. The last part, which we will be demoing as well too, is what we term to as service mesh, and that's a really hot topic in the industry right now. Basically giving specific identities to each workloads through a sidecar proxy using Envoy, and that gives us the capability to do a lot of manipulations from a layer 7 perspective, as well as giving you like the security of mutual TLS. Nomad is one of like those interesting products out there. I think like which basically does not have like the jazz, but a lot of like the super efficiencies of what a scheduler should actually do, right? I mean, from a scheduling standpoint, Nomad is one of the most efficient scheduler out there right now. It also is very flexible in the sense that you can actually deploy multiple workloads as needed. And also at the same time, it is the first scheduler right now that allows you to do multi-federation and multi-cluster deployment. And we will be doing some demos on that one as well for today. It's a very ambitious. I was thinking earlier today that like this topic actually started as a small like scaling and deployment topic that I was looking at, and then when you look more into details, it is actually a lot of like subtopics, so to speak, that can be discussed. So we'll talk more about it from a high level. We'll try to go deeper a little bit further to at least like show you some of the concepts and move forward with it. Like I mentioned earlier, this is actually like what we are going to be talking about, which is going to be mostly the Nomad and Consul layer. And we'll briefly talk about the Terraform and Vault in an auxiliary manner as well. With that being said, let me transition to the demo for us to see like how this actually applies in concept and as well as in practical sense. So this is what a typical Nomad deployment is, which is basically the basic topology for it. So typically with Nomad, you have a couple of servers actually that forms a quorum on the top layer that acts as a control plane, and we typically suggest like around 3 to 5 to make sure that like we have the proper sizing, both from an intercommunication layer as well as like from a failure standpoint, right? And we can talk more about the architecture at a later time, or I can send over some of like the links after this webinar regarding our reference architecture for Nomad. In addition to this, is that underneath that you'll have to have some like Nomad clients, which acts as a worker node in order for you to be able to schedule some workloads. And some of the predominant ones, such as Rocket and Docker, are the ones that get scheduled, and they're pretty much like your portable and your containers workload that can actually be scheduled on a regular basis. What you see here on the right side is Consul, and Consul acts as a couple of functions for Nomad per se. In this particular demo, we are using Consul as a means for service discovery for the infrastructure, which covers what Nomad servers are available and basically like how we can actually federate that into like other clusters. The other part of Consul is using it as a means of a service discovery, like a Consul DNS capability for your workloads, similar to like what you see with etcd. And in addition to that, it dual functions as a service mesh that we can actually take advantage of. So a very powerful feature. So we have here in this demo basically a deployment within GCP, and let's take a look at how that looks like. So what we have here reflects what we currently have in the diagram earlier, which is basically a number of servers pre-deployed on your behalf, along like with some Nomad clients as well. We did this like just for the interest of time, and just like do a segue with how we do this is we've deployed this actually using Terraform, using infrastructure as code. And the beauty that I've seen so far, being here at HashiCorp for the past year and almost 2 years, is that there's a lot of synergy with the product set itself in terms of like how the workload flows, right? So a big synergy is that like when you're deploying something like in a cloud environment, is that like Terraform is an amazing tool to use it, in addition to like on-prem as well. But at the same time, it has like great hooks into being able to deploy Nomad as well too, right? So here we have deployed Nomad here in a 3-node cluster in GCP, and basically have like one single client right now that's basically going to serve some of our traffic. And don't worry about it, we're actually going to add more clients to that as we move along. The other part of that is that there's a high integration and coupling actually with Consul, since Consul acts as a means for integration. It means for service discovery for any of like our infrastructure, right? So the Nomad client and Nomad server, as you can see here, are registered via Nomad for Consul, and we have the proper health checks around that as well too. And Consul itself has its own health check that basically defines like what like the serve availability is for memberships. So here, what we could do now is like let's deploy an application that we've been playing with earlier, actually with some of my teammates here, and this is what we term to as a fake service, which is basically a simple application that shows like a downstream and upstream application using HTTP, and then in that sense, that will segue into like the whole service mesh conversation using layer 7 as well, right? So here you can see that like we have a definition as a job from a root level, and if you want to think about job, you want to think of it like more of a pod, so to speak, right? Where it is like a deployment per se, where it basically defines like the resources underneath that, what are the network protocols that it needs to adhere to, right? Like what resources it needs to have, and so on and so forth. So within this like job definition, we have what we term to as groups, and groups are basically like if you think about it, are mostly like governance around like your containers. So we want to be able to deploy a Docker container using a task driver as part of that group. So we define the task driver over here, and we put in like the environment variables and basically the image that we need to pull down from GitHub. From Docker Hub. And then like the beauty of like having a console as part of Nomad is the integration for workload discovery, right? We can start with the service name, and basically that will give like some level of DNS capabilities. But as you can see here, we already have an outbound connect that basically determines what the upstream is. So what in turns happen is we basically inject this particular group, right, called web, with a sidecar container with Envoy, without the need of basically pre-populating or creating some orchestration outside that, such as an init container, which is amazingly cool, right? And for this, since like we want web to be exposed outside to my client over here, which I've given a public IP, we can now actually do like a one-to-one mapping for that, as opposed to dynamic map. and basically like also deploying payments, which is going to be the backend service or upstream service, and providing some tagging, which we'll be working on later as well too. So let's deploy this right to a run sh, and all this does, if we do a cat actually on run sh, is that we're deploying the job itself using Nomad. So it's a very simple like straight up directive. We can do a Nomad job run and then the file name, right? And when we do also need to be able to define what we term to as configuration entries in Consul. So a configuration entries, think of it as somewhat of a global definition in terms of like how it would process incoming requests. And we have a couple of those that we can that's part actually of the service mesh that that we can actually go through at a later time. But for now, like for this, service default payments that we see here defines that like the upstream service needs to be in the default namespace. If you're actually using the enterprise version, we can have like a different namespace for this, and what protocol it wants to receive, right? So if we do the run.sh, and we are deploying this right now, right? You can see from the right side that that job is actually now running. And so it's really, really fast. One of the things about Nomad is that like, because of like it's it doesn't take a lot of the other functions that other orchestrators do, and it does just one thing. All Nomad does is basically schedule workloads. So it's very, very fast. We can see here that it's already it has been scheduled. We've given certain priorities around that, and we can talk at a later time in terms of preemption as well too. And we can see that we've deployed 3 healthy instances. And if you take a look at back, like what we did is that like we basically deployed 3 instances here, basically 2 payments and 1 web. So a count of 2 of the payment group and a count of 1 with the web group, right? And here, the beauty of like the tight coupling and integration with Consul, it already registers that actually as part of like the service registry. So if we have the capability to be able to use Consul as a DNS, this would actually appear as an A record or an SRV record that you can actually refer to and manipulate accordingly as well. So that's done. Let's take a look at the public IP address that I used here. Right? Public IP address for Nomad is actually this. And we'll just use another session here and call it 1990. So we are actually having a problem called upstream requests, and that's not necessarily a good thing. But let's take a look at what we can do with this. So, it probably is just the cache actually. So there you go. We basically had the upstream and the downstream from both webs and payments, right? So that's good. That's awesome. So what we could do from now, like before we jump into the second one, let me run actually the power of Terraform in order to be able like to create the secondary data center as well, and then that will actually start it out for us. So here, similar thing: 3 Consul servers, 3 Nomad servers, and let's start with one like Nomad client to start with, right? And all you need to do is to clear Terraform plan. This is where like the Nomad, the demo gods actually needs like their benevolence on us and this one, just to make sure that it all runs. Demoing like one product is hard enough, but demoing like two products at the same time is actually like interesting. So bear with me in this one, folks. So while we're doing this, perfect. So let's do a Terraform plan. Apply, sorry, how to approve. And that will take a little bit further. Let me talk about the next phase. So the next part of this is basically moving more into a cloud multi-cluster deployment. What we want to do here now is progress actually in terms of our layer 7 capabilities within like the Nomad locally first. I'd like to do like more traffic splitting. It's actually within the Nomad clients. And basically, hopefully, if we have time, we can also deploy like the KVM QEMU driver. At the same time, we want to be able to use other workloads. So what we're going to do is we're going to deploy our mesh gateways, actually, not in a Docker container, but using the raw exec, which basically means that we are going to run like an executable past the arguments underneath actually like the file system that the Nomad client actually executes. So we have the Envoy proxy installed here. We have the Consul server obviously installed here as well. And we'll be using that in order to be able to federate a mesh gateway between these two between these two locations here, within these two Consul servers. The whole reasoning behind that is that like when we deploy the mesh gateway, it gives us a lot of benefits in terms of being able to tunnel through using mutual TLS without worrying about overlapping IPs and setting up like TLS actually between like the two applications. So the sidecar proxy handles all of that. Consul bootstraps actually the sidecar proxy based on like the configuration that we're going to be doing as part of this demo, and we will be able like to do some redirects actually across different DCs, as well as to be able to split the traffic accordingly in different locations as well too, right? Let's go through that one right now. So hopefully my deployment right now is, it's actually completed. That's perfect. So we've seen so far here that like we've basically deployed one deployment with the Consul with the Consul service, and it's coming back with the payment response of V1. Let's now try like traffic splitting between these two actually. So the way to do this is we switch back into like one of our back into like our other terminal, CD. And let's explain this a little bit further, right? Like with the traffic, with this particular service, there are three different kinds of configuration entries that needs to happen here to configure like the manipulation of layer 7 incoming traffic to these services, right? So the first one is we're gonna do is basically deploy another instance of the payment service as an upstream, and tag that with a V2 as a metadata to differentiate it a bit, right? The second part for that is that we'll need to have a service resolver to be able to put a placeholder on what is version 1 and version 2. So the fake service 1 actually has this as a metadata version of 1, and as you've seen earlier, like the version 2 has a service metadata version equal to, right? In addition to that, I think the thing we had to talk about this beforehand first is that we need to define what is the prefix that points to this payment service. So what we're saying here is anything that's like the root after the URL actually is like pointing to the service, payment service, and that's where it's going to be resolved. Now, once it passes through to the router, basically the service splitter determines like, hey, how do we actually do this, like in terms of like manipulating it? And there's a couple of ways to do that. One of the ways that we do is basically through the splits directive, wherein like we can do specific weights that needs to total into 100. So what we're trying to do here is split it into half. 50% that goes into the V1 subset, and 50 actually goes to the V2 subset. Okay. So in total, like if when we start actually like putting a request into the slash prefix of this particular URL, so to speak, we are going to be pointing to both sides. So let's see that in action. So I've created a script in the interest of time, and all we need to do is run that. Perfect. So what we did here was that we deployed that we basically deployed that Nomad job, similar to what we've done with the first job deployment. The second part is we wrote the configuration entries in terms of like this directive, which is going to be Consul config write payments resolver, right? And that is going to be a cluster-wide deployment. We can have the options to be able like to reduce it more on the service level, but just for this purpose, we're doing it actually at a cluster level. So if we go back to our jobs, now we see that that fixed service V2 has been registered and basically has a count of 2 that we deployed accordingly as well, right? One thing that we want to make sure that we can see as well here too is that when we deploy a job, there is a term what we term to as an allocation, which means it is placed in under it is an ID where it is actually placed in under a client Nomad cluster, right? So an allocation gives you like the resource utilization, and it also gives you like some of like the lifecycle capabilities as well. So here we have payments, and we do have the proxy that's also added to it. Okay. So if we go back here and we start running, since this is a prefix, we start doing this a couple times. Then we see the response payment from V2 actually works. So as you can see here, like in terms of like how in the demo, it's very straightforward and somewhat repetitive because of like how the workflow goes. It's very straightforward. It's an easy like change actually in terms of the configuration in order to like this in order to define this. It's not like where like you have another orchestrator where you need to put another service mesh on top, and it's a different way of configuring it. Everything here actually with Nomad plus Consul is very integrated per se. Okay. So now that we have actually created the other cluster, as you notice that as soon as like we did the join, because of the virtue of Consul, we now have 2 data centers here. One is basically the GCP, and one is basically the GCP East, right? So we have federated both of this as part of like the automation that is created. All we did was basically do a Consul join, right? On this side too is we did a Consul join as well in terms of the two Nomad clusters. So now that we have like we actually have the capability to manage 2 clusters within just one single endpoint. Data actually is not replicated between these 2 clusters, right? It's just a matter of like being able to replicate like some of like the if we're talking about the enterprise, like we're basically like replicating some of like the Sentinel capabilities, the ACLs and such, right? That being said, now that we have this region created as East, why don't we deploy another deployment here to show like the ease of being able to traverse one cluster to another cluster, right? As you can see, it's the same. It will be the same procedure that we are actually going to be doing actually. So if we go back here, We now switch to the three mesh federation directory. Let's see, three mesh federation directory, and it's basically the same. It's basically the same pattern as well too. We deploy another service. This time around, we're not deploying in GCP. We're deploying in region East, and that's going to be actually under the data center East US, right? We're giving it a different name this time around, named payment service, and we'll put a v1 tag around that as well as a version tag, right? At the same time, nothing else actually changes, right? All the things that you'll need to do is like making sure that the service name is the group name is different, and that could be the same too, since it's being deployed in a different data center. But everything actually is being managed as part of like the configuration entries. So what we're saying here in this router is that in addition to the prefix that we had earlier, which is basically implied, what we could do is that we can add another two prefixes. Like if I have a /payments prefix, send me to like the local cluster. If I have a /Azure prefix coming from GCP, send me to the payment actually in Azure. Really powerful stuff, right? And in order to do that, the payment Azure needs to be defined here. Payment Azure, if you take a look at the resolver itself, it basically points into the payment service in the East cluster. So if you take a look at here, the East cluster, we actually haven't deployed it yet, but like once we deploy like that big service B3, we'll see the payment service over at this section as well, right? The third part for it is like there's no splitting involved. We're just splitting the same thing together. But so the qualifier here is that if we see as a path prefix of Azure, send it over to the next cluster. Now let's try to see how that works. So if we do a run on this one, right? All we need to do is basically just run this Nomad job, and you're basically still pointing to the GCP region as a virtue of this. Actually, if we do this one here, actually, sorry, my bad. Example jobs. Three mesh federation. Oh. Consul connect. If I can type, see the three mesh federation, and then let's run these. Actually, if we run this one here, excellent. So what we're seeing now, if we go to the east side of the cluster, is that you can see that payment service is now actually created. It's still doing its check, that's why you see an X, but once all those checks are done, it will actually be all green. If we go to the east, to the east side of the cluster, we now see fake service there as well too, basically with a count of 1, and it's still actually just like deployed accordingly, right? Now we have these three things that we actually took a look at earlier. Let's like deploy all of those. So this is actually for east. It's very straightforward. If you do want to check them, what we could do is like, we could do a specific, instead of doing a console config write, we can actually do a console config read, define the kind as well as the name, and we should be able to see it. So as an example, if we want to do a console config read -kind solver, which we just created, we should be able to see like all the metadata that we basically placed there, right? So let's try to see if this works or not. And I hope the demo gods are actually on our side. Everything seems right, everything seems good. All we're trying to do here is basically go through. If we do the payment, we do the payments here. it actually goes through, right? And if we go to Azure, there is a problem. I'm not sure what's going on. Let me take a look at this. So I think I know what's going on here on why this error is occurring. If you think about it, we are trying to connect two separate services in two different clusters with no intermediary to basically act as a bridge between these two. So if we take a look at the architecture we were looking at earlier from a topology standpoint, is that what basically joins these are basically the gRPC as well as like the as well as an RPC Nomad join going to these two servers. However, the definition that we created actually as part of the mesh gateway in the configuration entry requires basically a mesh gateway that was set for local, which means that all of our service proxies, or basically envoy proxies, needs to go to the local proxy and to the local proxy or gateway, and forwards that to the remote gateway. So let's take a look at this and see what happens. So a kudos actually to the one who created this, which I basically just copied from him, is basically Christian Ramirez from Digital and Us. Thank you so much for contributing to like the code base. I did see this example, which basically gives me another example of in terms of being able to give in order to be able to show like two different types of workloads in one single server, right? So in order to do this, what we could do is basically take a look at how the mesh gateway was set up. Take a look at the two gateways that we're creating. They're basically jobs as well that will be residing in each of those clusters. And when we deploy actually the GCP Nomad job, it basically deploys in the GCP side of things and basically sets that cluster accordingly, right? Same thing with the Nomad side. So these two clusters will be bootstrapped by like the its corresponding Consul cluster. But the information between those two are shared because of the gRPC federation that was done automatically on this behalf, right? So if we take a look at this, we have the 52.191, which is basically the public address of like the client that it's residing at. The other one here too is basically the public address of the other client on where it's actually residing at as well too. So you notice that we are not using Docker here, we're using raw exec. So this is another task driver within Nomad, which basically runs a specific script or binary underneath the client OS. So if you want to run a script, let's say like that's like something that does something on your behalf, like maybe like some housekeeping, or maybe a specific binary as well too, or a Go application, raw exec actually is a very powerful task driver that you can use. Other options that you can do with this is basically maybe if the runtime is actually available within the Unix environment, you can also run .NET Core as needed, right? So let's try to like install this one and see like how that works, and hopefully like this one actually communicates together. So in order to do this, we need to go back into like the mesh gateway. So I've created actually a mesh gateway directory. Do an ls over here, and basically it's as easy as like basically running those two jobs. If we do a cut on run.sh, all we're doing here is basically deploying those two jobs accordingly. So without further ado, let's do a run.sh here. And those should be good. Awesome, they were successfully allocated. Let's take a look at the jobs. So first and foremost, since like the central is the primary, we can see that it's running, it's allocated, and it's healthy. Perfect. Now let's go back to the other portion of it. This is going to be the east side of it as well. Azure Gateway, perfect as well too. Awesome. Now that's actually deployed. Let's try to see if this actually runs. Voila. Now we're basically communicating to the two different clusters, right? Service actually is for Service Web is residing on GCP, and the other one is actually residing in Azure. So pretty neat stuff. So if you have some use cases where you need to traverse different clusters, maybe because of from an isolation point of view where they can't share the same control plane, and this is actually a perfect use case for you as well, right? The one thing that I want to show more here is let's close this all of this is the TFRs. I mentioned earlier that a region constitutes somewhat of a cluster, and then the data centers actually are where different locations are, right? So if we take a look at this, I basically created like two different things, which is basically Azure Nomad count 0 and Azure Nomad Northern count equals 0, right? And for the sake of posterity, let's start provisioning those as we are about to come to the end of our webinar. And all we're trying to do here is basically do a few things, right? From a deployment point of view, we're trying to say like, listen, if I want to peer, I don't need to be restricted to a cloud region like an East US 2, since like there is no there is not much of a sensitivity in terms of latency between Nomad server and the clients, right? It's only between the Nomad servers and its entities that needs to have like 10 millisecond round trip between each other. Then I can technically put this in a different location where it's not where it needs to reside to, right? So let's say like Azure East US 2 and Azure East US are somewhat of a peer data center where they're probably like 160 miles apart. Then that's a good way of being able like maybe to put like some of like your like closely knit applications. The other portion too is being able to use a different location to let's say in Northern EU, which has a lot more latency, a lot more distance, and bring in like more the concept of edge computing actually, right? So let's say like if I have a Tomcat server that needs to be or a CDN that needs to be closer to a customer that actually resides in one client, then that's something that we can actually do as well. All in all, right, this basically encompasses a single region, regardless if like your Nomad clients actually are not located within the same cloud region. Really cool stuff. And I can actually, as part of like this deployment, we can also basically start deploying through like the GCP and create a fully federated job, which we term to as a multi-cluster deployment that basically gives you some strategies in terms of how you roll your applications from one data center to a different data center across the board. Now let's try to do that as well too, and then that will be the final one that we have. So real quick, we're going to be just talking about the new multi-cluster deployment actually that came out with our latest release actually in the enterprise version. The reason I'm bringing this up is basically some of the cool features that's actually added to it. So instead of having individual jobs that you want to run, you want to be able like to do some level of coordination across multiple region, especially if they're all federated at the same time. Then what we could do is use this feature. I'll be showing you this feature, the job specification per se. Looks like our perfect. So all of our nodes has been deployed. I deployed one actually in northern EU, another one actually in US East too as well too. So like in our deployment here, we have a multi-cloud example where basically we are doing some coordination from a strategy point of view. So if I want to be able to deploy something in central and at the same time on the east and basically put a level of parallelism, and then if something happens to a rollback as needed, but basically making sure that it's a consistent deployment across these data centers accordingly, then this is actually something that you may want to take a look at. It also gives you some like some health checking accordingly that like Consul can actually give you on that side, right? Especially like if you have like the health checks involved in it. We're only deploying actually a small Redis a small Redis image, which is basically the tag 6.0. Let's do that actually right now, and we'll call it a day. Thank you so much for bearing with us on this one. Sorry for the inconvenience and some of like the errors that we're getting. Let me see here. CD deployment. All we need to do is basically do a Nomad job run, then basically multi-cloud at Nomad. Yeah. So with that being said, we should be seeing the job actually being executed. It's a multi-cloud example. It's running actually in the region side that we've specified. We placed 3 of those actually in each side, and then basically specified also like the Northern Europe and the East too. Can't really see the allocation right now. 2 allocations over there and 1 allocation in US East 2, and also on the central side, basically covering the same thing as well too. So it's a really cool feature to be able like to have a consistent deployment across the board. I know I just like skimmed at that one. If you definitely are interested, let us know, and we'll gladly like walk you through like to a more in-depth detail on that. So with that being said, we are actually at the end of our webinar. As you can tell, like it's a very easy workflow process that we actually do with Nomad. At the same time, it's highly scalable. We basically have done like 1 million containers like in 5,000 nodes like 2 years ago, and I'm sure there's a lot of efficiencies that's been done since then. And as you can see, we're using Terraform. The scalability is pretty much easy. You're not restricted to one single cloud region. You can actually go further than that because of like the concept of like data centers, the data centers and regions. The other portion of that too is that like you can do diverse workload. I've only covered 2. Was still gonna do QEMU, but that didn't go through. But we'll set up some other webinar actually to like show those legacy workflows as well. The importance of Consul as part of the service discovery and between like the infrastructure as well as like the workloads themselves, and like showing you the last part of like the true multi-data center and federation for deployments. Though briefly, but I think you get the gist on like how that's being deployed, right? So with that being said, that basically brings us to the end. Let me take a look at the chat. I know there's some questions here. Yeah, I apologize, guys. Like what happened is that like I was using this OBS software like Twitch to do an overlay to be cool a little bit on this one, but I think that dropped my frame rate a lot. But we'll be sending some of like the higher resolutions since like we're recording this internally anyway.
Yeah.
Brianna, I'm at the end, so I'll turn it over to you.
Perfect.
Q&A.
Thank you, Mark. And as you mentioned, we'll send over a high-res version. So if anyone has any questions, please, we have a few minutes left, so feel free to add those in. But the one question we did get is the mesh gateway only required in a multi-cloud architecture?
Oh, that's actually a good question. Right now, I do have a couple customers who's asking me more into a multi-subscription. So let's say like if I have like it doesn't have to be a multi-cloud. It has to do more with what your logical segregations are. So let's say if like you have customer A needs to talk to customer B, doesn't need to talk to customer B, but they have a shared service in, let's say, AWS or maybe in Azure for their own subscriptions, you can definitely use that. When and the power for it is that the one thing that comes out of mind is the capability to do overlapping IPs, right? Because what it does is that when you send it to the mesh gateway, then and then even though like you have the same subnet ranges actually in different subscriptions, even in the same cloud, and what happens with that one is that it wouldn't matter. There won't be any like IP collisions whatsoever, right? The other part of it too is that we can now allow intentions between. So like if you have multiple services in one namespace here and another namespace here in Nomad terms, then that can actually be done as well.
Thanks, Mark.
Go ahead. Sorry.
Nope, I said thank you. You had any more?
Oh, we have Dana actually asking these questions. Can Sentinel enforce policies and multi-cloud scenarios you presented? So I've only played with Sentinel policies actually in a local cloud, but I did have a conversation with one of my teammates who is the SME for Sentinel, Roger Berlin. What we're gonna do is we can actually I'll have to verify, but what my understanding is like whenever you similar to intentions, you can or if you're in the concept of the service mesh, then like you can actually replicate those intentions and Sentinel policies as well in the enterprise phase. But I'll double check and I'll definitely test it out. And then Brianna, is there a way that we can like repost those questions so we can answer them as well too when we publish this?
Yeah, we can add them to the resource library with the answers.
Awesome.
Okay, perfect. All right, so that looks like the last one that came in. So thank you, Mark, for answering those. As I mentioned at the beginning, the Hangout was recorded, but because it was low res, we'll add in the high res version of the demo before we send it out to all of you and put it on the resource library. So if you liked what you heard today, want to start exploring Nomad and Consul more, I encourage you to check out our Learn site, which is learn.hashicorp.com. And we also host a lot of virtual workshops. So if you're interested in Nomad, Consul, or any of our other tools, please do feel free to check out our website, our events page, as we're posting ones for August, September, October over the next few weeks. And then I hope you all enjoyed the Hangout today and have a better understanding of how to deploy a polycloud environment using cross workloads. So thanks for joining us today, and thank you to Mark for his time. Thanks all.
Thank you, folks.
Bye.